In past sections, we've discussed how to conduct a hypothesis test for the mean of a population. For example, we might want to test that if the mean of a population is smaller than, say, 0. Okay? Now that uses a less than symbol, so that would be our alternative hypothesis, which means our null hypothesis would be that mu is greater than or equal to 0 using the opposite symbol. Okay? We've already learned how to do this. In this section, we're going to expand on this idea a little bit and look at how to conduct a hypothesis test to compare the means of two different populations. So instead of doing this, maybe I'm interested in whether the mean of one population, let's call it mu sub 1, is less than the mean of another population, let's call it mu sub 2. Okay, now this is a different beast because we have two different populations, which means we don't know the mean of either of these populations. We will need two samples, one from each population. Okay, the null hypothesis, if this were all our alternative hypothesis for this example, would be mu1 is greater than or equal to mu2. So how do we go about actually conducting this hypothesis test? This is a little tricky because we have two populations, which means we would have two sampling distributions that we would have to work with, right? So we're actually going to do a little trick first to make this a little bit easier to work with. Instead of thinking about the hypotheses in this form, what I'm going to do is I'm going to subtract the second population mean, mu sub 2, over to the other side of each of the inequalities. Okay? So instead, I'm going to get the hypotheses mu1 minus mu2 is greater than or equal to 0. Mu1 minus mu2 is less than 0. Okay? Mathematically, these are equivalent statements. These hypotheses are equivalent to these hypotheses. But it's going to be a little bit easier for us to work with. Okay? So the trick here that we're going to use is instead of thinking of this as two distinct populations, we are going to create a new random variable that will define our sampling distribution, which is just going to be the mean of the sample from the first population minus the mean from the sample of the second population. Let's call this new variable d. Okay? By looking at this as only one variable instead of two distinct variables, we're able to use only one sampling distribution. Okay? So to conduct our hypothesis test, the sampling distribution we are going to use is going to have the following properties. Okay? First off, the mean is going to be the mean given by our null hypothesis. Remember, we assume our null hypothesis is true. Okay? So it's whatever we are assuming about mu1 minus mu2. Okay? That is going to be our mean of our sampling distribution. That's going to be what we would expect most of the time if we take a sample from the first population, subtract the sample from the second population, subtract their means. We would expect most of the time to get mu1 minus mu2, or to be close to that value. Okay, so that's the mean of the sampling distribution. The standard error of the sampling distribution is going to be a little bit different. Square root of, we're going to use the sample standard deviations from our two populations, from the samples from each of our populations, okay, where we square them, and then we divide by the sample size in each case. So for our first sample, we divide by the sample size from that first sample. For our standard deviation for from our second sample, we divide by the sample size of that second sample. We add them up and take the square root. That's going to be our standard error. Okay? Now, because we are using the sample standard deviation, S1 and S2, and not the population standard deviations, we need to use a t-distribution here. Okay, so we're going to use a t-distribution for our sampling distribution. Where the degrees of freedom is the smaller of n1 minus 1 and n2 minus 1. So we're going to look at both our samples. The sample 1 with size n1, sample 2 with size n2. Whichever one has the smaller sample, that's the one we use to determine our degrees of freedom. So we have to be a little bit more thoughtful when constructing our sampling distribution here. Okay. Once we have that sampling distribution, though, the process for conducting our hypothesis test is the same. We're going to state our null and alternative hypotheses. We are going to assume the null hypothesis is true and then identify the sampling distribution. This sampling distribution, that's the biggest change we're dealing with here. Okay. Once we have that sampling distribution down, we can find the p-value. Okay. We're going to do that by finding our t-score. Our t-score is the same as it always is. We always take our point estimate we're going to subtract the mean of the sampling distribution. Let me call it distribution mean. And we divide by the standard error. Okay, so what would that look like in this case? What's our point estimate? Well, the distribution we're looking at is the distribution of this random variable d. The distribution of the difference of the sample means from two samples from our two different populations. Okay? And this is what we are hoping to estimate. We want our point estimate to estimate mu1 minus mu2. Okay? So the point estimate for mu1 is the sample mean from the first sample. The point estimate of the population mean from the second population is the sample mean from the second sample. So that's our point estimate. This together, x1 bar minus x2 bar. And I'm going to subtract the distribution mean. We go up. We've already identified our distribution mean. Whatever mu1 minus mu2 is by our hypothesis. Whatever that null hypothesis says it is. Okay, we're assuming that's null hypothesis is true. So mu1 minus mu2. And then we divide by our standard error. This is our standard error. And so that's what we are going to divide by. And so that's how we are going to calculate our t-score for this kind of a problem. That is how we are going to find the p-value. And then once we have the p-value, we draw conclusions the same way we always do. We're going to compare the p-value to the level of significance alpha, determine whether or not we should reject the null hypothesis and accept the alternative hypothesis.